Hey, I'm Tim, and I'm an engineer at Streamlit, and it is still coronavirus times, so I am still recording out of my spare bedroom. This is the second of a two-part video series on building custom components for Streamlit. So in the first video, we set up our development environment. We rebuilt the Streamlit component template project in order to understand it better. And then we went over the Streamlit execution model, which has some non-obvious implications for how components work under the hood. In the second video, we're going to be creating a new, pretty simple component, a discrete slider using the Material UI framework. And we'll be discussing basic styling issues, integration with other front-end libraries, and packaging our component for distribution on PyPI. Both of these videos are geared towards developers who have some experience with Streamlit and Python and some passing familiarity with JavaScript or TypeScript front-end development, but you do not need to be a front-end expert to get the most out of them. Okay, so for the second part of this tutorial, we are going to build a discrete slider using the Material UI framework. We're going to build something that looks a little bit like this. The idea here is to create something similar to st.radio or st.multiselect, where you can pass a list of strings and have them arranged along a slider, and the user can pick one of those strings with the slider thumb. And I chose Material UI because all of Streamlit's UI widgets are built using the base web UI library. So I have not actually used Material UI before, so we will all be learning something. So to start with, we are going to do some very straightforward housekeeping. Currently, our component is named My Component, and this is a bad name. So we're going to rename it to Streamlit Discrete Slider, which isn't a thrilling name, but is nicely descriptive at least. So let's rename the Python code first. I'm going to rename this top-level directory to Discrete Slider. And then everywhere that we're using My Component in this code, I'm going to also rename that to Discrete Slider. And then finally, the setup.py file is part of the PyPI packaging process. And among other things, it determines the name of our package on PyPI. So let's call this Streamlit Discrete Slider. Now I'm switching over to WebStorm, and we have renamed the directory out from underneath ourselves. So I need to open this in its new location, Discrete Slider front end. And here we have this My Component class. This is getting renamed to Discrete Slider as well. Let's change the name of its file, Discrete Slider. And in index.tsx, change all of these references to Discrete Slider. Now I'm just going to npm install and make sure that our node modules are set up. Okay, and then finally in the front end's package.json file, we will name this Streamlit Discrete Slider as well. Okay, so the next step is to really quickly run this component and make sure everything still works. So I'm running npm start from the front end. Now I'm switching back over to PyCharm. And let's run Streamlit run Discrete Slider init.py. Looks good. Okay, so we are going to be spending much of our time in front-end land, which means we'll be using WebStorm primarily for this next chunk of work. So I'm just going to leave our trivial Streamlit app running in PyCharm and switch over to WebStorm. And the first thing we want to do here is install Material UI into our project. They have an installation page that tells us the npm package name. Okay, so the instructions say run npm install Material UI /core. Okay, and with Material UI installed, I am going to remove most of our existing component front-end template code so that we're at a blank slate. So we're going to remove state, which we're not going to use. We're going to remove most of the render function, this onClicked callback. And from our render function, we're just going to return a string, discrete slider. And now I'm going to restart the front-end dev server to reload our page. We can see our component right now is just a string that says discrete slider. So Material UI has a bunch of sample code on their website that we can almost just copy and paste into our project. So they have this restricted values slider. I'm going to show the source. And inside here, we can see that there is this slider object. This is what we want to return from our render function. So I'm going to copy and paste this into our render function. And I'm going to get our imports correct. And it looks like there are some helper functions and placeholder data that I'm also going to paste into here. Okay, and finally, I'm just going to clean up this placeholder data so that it's not taking up as much space on the screen. Right, so I've hit save and recompiled, and now we have this discrete slider that's showing the placeholder temperature data that the slider code sample uses, but it clearly does not look very good. So specifically, the content is being cropped here quite a bit. So we need to get a bit into the styling weeds for this next section. Depending on what you're doing with custom components, this may never be an issue. Like if you're displaying a nicely rectangular piece of content, like you're showing a video or a frame chart or something, you won't have to worry about this. But for this example, using Material UI, we are going to need to tweak our component styling to fit its iframe properly. And the reason that things look wrong here is that every Streamlit component is contained inside an iframe. And an iframe is rectangular, and any of its content that's drawn outside of its bounds is simply cropped by the browser. So by default, when a Streamlit component is loaded, the component computes its own bounds, and it tells the Streamlit app, hey, here are my bounds. And then the Streamlit app resizes that component's iframe to match the bounds that it reported. You can override this bounds computation in your component implementation, but by default, the component template code assumes that all of the component's content does not extend beyond its CSS margins. This Material UI slider is specifically designed to overflow a bit beyond its margins, which results in this cropping. And so to fix this, we're going to use Material UI's styling system. And their styling system happens to come in two flavors. There is a hook-based styling system and a class-based styling system. Our React template is class-based and not hooks-based. And if that distinction means nothing to you, it's fine. You do not need to understand React hooks or even know what they are for this tutorial. So we are going to fix our bounds issue by adding some custom styling. Actually, first, I'm just going to get rid of this giant guitar pick, which is almost not even visible here. I'm going to turn this guitar pick off because it extends way beyond our bounds. This also means that I can get rid of this value label format, function, and property. Okay. So Material UI has sample styling code on their website that we can basically just copy and paste, which I'm going to do right now. Material UI has this styled function, which essentially takes a Material UI component and some CSS styles, and then it spits out a new version of that component that, that has those styles applied. The example code shows how to make a styled button, but we can easily adapt that to make a styled slider. Call it styled slider. And we don't care about any of these styling bits right here. Let me plug our styled slider into our render function. So for our purposes, all we really care about is the margin style property. We want to extend this slider's margins so that its visuals fit inside its iframe bounds. I diddled with the values a bit beforehand, and I came up with a vertical margin of 7 pixels and a horizontal margin of 20 pixels. And this gets us close enough to where we want to be for this tutorial. Right now, our left and top margins look a lot better, but now the right side of our slider is being cropped even more, like we can't even see the right side of the slider. And this is because we need to set the slider's width properly. By default, the slider's width fits its container's width. We've now added some margin to the slider, but the width has remained the same, so now it's overflowing its bounds even more, so it needs to shrink. And a Streamlit component's width is defined in its props object, which means that inside any of our component's class functions, we can access this.props.width to get our width. So if I were to do width equals this.props.width from inside our render function, this width value is what we're looking for. So we need to tell this styled function what our desired slider width is, but styled slider is currently a value that's declared outside of our class. So to make this work, we'll need to pull that definition into the component and then construct its width and margins dynamically. Okay, so I'm just going to move this styled slider declaration inside the render function. And let's create some constants for our vertical and horizontal margins. And for our width, we are going to use this.props.width minus h margin times 2. And we'll use some nice formatted strings for the margin values. So I just hit save, and with this set of changes, our slider fits inside its component bounds much more nicely. If we were to drag the window, the slider resizes. Okay, so our API goal with this discrete slider is to have the user pass a list of strings and to have those strings arranged evenly across the slider. So that's what we're going to tackle next. First, for simplicity's sake, I am going to get rid of this get aria value text property from our slider. This aria value text business, this is an accessibility good practice. It's something that you should use if you're shipping a component. We are going to skip it for the purposes of this tutorial. And currently our slider is showing these temperature values with these associated labels that comes from the placeholder data that the Material UI website supplied us with. We are going to create our own new placeholder data in place of these marks, right? So we're gonna make some data that we are pretending is being sent to us from the Streamlit app. Okay, so I'm gonna make a list of options. We need to pass a list of these value label pairs to the slider in order to get it to render properly. So since the slider wants a list of value label pairs, we're going to create a simple create marks function. And it is going to take an array of labels, and it's going to return an array of objects. So we're creating a simple create marks function that maps each label in our label array to a value label pair where the index, return labels.map, label index. So where the index of each string in our options list is the value and the label is the label. Okay, so let's update our app to use this new create marks function that we wrote. We're going to pass it our pretend options. And I'm going to get rid of this old placeholder marks data and hit save. And things look pretty terrible. A big problem is that our values are clearly not evenly distributed across the slider. So let's fix that first. This default value of 20 doesn't make any sense. That made sense for temperature, but not for us. We want a minimum value of 0. And we want a maximum value that's equal to the length of our options list, -1. Right? And now we have a slider that's arranging these strings evenly. So if we were to change the options, do not like. So I've added some new options. I'm hitting save. We can see that things get laid out nicely. Okay, so now we're ready to actually define our API. And this part is very nicely straightforward. So in the last video, we learned that we can pass data to a component via named parameters in Python and receive that data in the this.props.args dictionary on the front end. So let's switch back to PyCharm. And our discrete slider is going to receive a list of strings, which we are going to call options to match st.radio and st.multiselect. Let's get rid of our greeting and name parameters, which don't have any good meaning. So our discrete slider function is going to take options, and we're going to pass this options list to the front end via a named parameter that we will also call options. And let's fill in some new data here. So, right, so we're passing some new data. We're passing this new list of strings to discrete slider. I've just hit save. we can see that actually nothing on the front end has changed yet because we're not actually doing anything with the data that we've received. So now that we are sending data to the front end, let's switch back to WebStorm, and we're going to pull options out of this.props.args. So options equals this.props.args. This is a dictionary, and we know that the key that we're looking for is also called options. I'm going to get rid of these placeholder options up here and hit save. And here is the data from Python. And if we change this data on Python and hit save, it all works as we would expect. Now, there is one more thing remaining for this API. When the user selects an option on this slider, we want to tell the Streamlit app what was selected. Slider has an onChanged committed event that we can handle. OnChange committed. And this is a function that takes two parameters called event and value. Value is what we care about. It's the value of the item that the user selected on the slider. And our slider values are simply indices into our options array. So we can send the selected option back. Let's get the selected option by indexing into our options list with the value argument. And then we call streamlit.setComponentValue with the selected option and hit save. And now, as we change the value of the slider, we can see that we are returning the selected string back to Streamlit. So let's just write you selected clicks, and let's call this selected value. So cool. This component is almost shippable. We just have a few odds and ends to take care of first. So first, we should make sure that the component becomes disabled when Streamlit sets the disabled property. If a Streamlit app is killed, all interactive widgets and components will be told to disable themselves because there's no running Streamlit app to send updates back to. And we can handle this scenario pretty trivially. We just pass this.props.disabled property through to our slider instance. So I'm going to add a new property here. Styled slider understands the disabled property, and we just pass this.props.disabled. I hit save, and now if I switch back to PyCharm and kill our running app, we can see, so Streamlit is no longer running, our web page is still showing, and our component is properly disabled. And if we were to restart Streamlit again, our component is re-enabled. And finally, the last thing to do is to get our component ready for distribution. So if we ship this component to other users, they are not going to be running its front end from a Node dev server. Instead, we compile our front end code and we tell Streamlit to serve that compiled code from disk. So I'm just going to remain in PyCharm for this part. We are going to switch to the front end directory, and then we are going to run npm run build. Okay, and if we list this directory, we can see that this build directory just got created. So now we need to write a little bit of boilerplate to load our compiled code from disk. This code is all included in the component template, but since we're rewriting everything ourselves as an exercise, we are going to write it ourselves. First, we get our component's root directory path. So this code is giving us the path to our component's root directory. And from there, we're going to use that to get the front end build directory that we just npm built our component's front end into. Builder equals os.path.join rootdir front end build. And then finally, we can pass that build directory to declare component with the path parameter. Now, for convenience, it's nice to create a release flag in our code so that we can easily toggle between development mode and release mode. So when we are in release mode, we're going to pass our build directory path to declare component to have it serve our compiled front end from disk. And otherwise, when we're not in release mode, we delegate to the Node dev server via the URL parameter. Okay, so let's see this in action quickly. In WebStorm, I'm going to kill our dev server so that we are sure that it's not running. And back in PyCharm, I'm going to set the release flag to true, and then Streamlit run discrete slider init.py, and everything works as expected. Node and the Node dev server is no longer involved. Our component is just Python and some static compiled front-end code that we serve from Python. Cool. So we are ready to ship our component. If we want to keep this testing code inside our component for testing, then we should only run it when we are not in release mode, of course. And our final step here is to build a wheel file and upload it to PyPI. I never remember how to build a wheel, so let's just follow the instructions from the Streamlit docs. The first thing we need to do is edit this manifest.in file, which tells the Python packaging code where our assets live. So in this case, we want to include the front-end build directory in our Python wheel. So, and next from the terminal, we run python setup.py sdist bdist wheel. Boom. And now we have this dist folder. And inside the dist folder is this .whl wheel file. And if we were going to distribute this component, we could simply upload that to PyPI. And that is it. Okay, so that wraps up part 2. We will post a link alongside this video with the discrete slider project code. And if you're interested in learning more about Streamlit components or developing your own, please check out the Streamlit documentation, which goes into much more detail. And also visit the Streamlit forums if you need help or want to show off your work or just want to say hello. We have a very active and welcoming community of developers. So thanks very much for watching, and please let us know if you would like to see more of this sort of video.